Hello and welcome to today's video. In this video, we are going to study about the soil taxonomy that is given by USDA. So USDA means United States Department of Agriculture. Okay, so this soil taxonomy is given by United States Department of Agriculture. So now let's see what are the soil taxonomy that we are going to study. See, here I have written a here we can see that here we have the orders of soil that are Entisol, Inceptisols, Mollisols, Alfisols, Spodosols, Ultisols, Oxysol, Aridisol, Vertisol, Histosol, okay. And then we have two additional soil, that is Andisol and Gelisol, okay. So in this video, we are going to study about all these 10 soil orders. So before studying about all these 10 orders, I would like to clarify some of the important information that you should know before knowing all these soils. Okay. So first of all, what are the clarification? See, a minimum questions would be there in your brain that before this USDA soil taxonomy, the classification of soil, what are the other classification there was there? This kind of questions would be there. How before this 19, because this was the year of 1975 when USDA given its soil taxonomy, it published their soil taxonomy. But before that, there were some other methods. Okay, so early Russian paradigm. Okay, what happened before in the late 19th century during the 1883, Docuchaev. Okay, Docuchaev given the soil. Classification on the basis of this concept, that is CLORPT. What is CLORPT? CLORPT, CL for climate, okay, O for organisms, R for relief, P for parent material, and T for time. So this system introduced a revolutionary concept that soil is a natural interdependent body formed by. These are the factors. The CLORPT is the factor that form a soil. So on the basis of the genesis, of soil formation, on the basis of the genesis of the soil formation, the Russian geologist, geographer, and scientist Dokuchaev has given his classification of soil. Okay, it categorized soil broadly as zonal, climate driven, which has zonal, okay, and interzonal, means condition driven, like waterlogging and all, okay, and azonal means young undeveloped. Azonal means young undeveloped, means those soil which do not have proper soil profile, okay, which do not have proper soil profile. Okay, so here one question is, what is soil profile? I hope many of you already know what is the soil profile, but let me again tell you what is a soil profile. Okay, if you know this part, you can skip this part. So soil profile means we have studied it in our standard 8, 9, 10 or other classes, that soil have some profile. We say it a horizontal layer like O, A, E, B, C and R. I hope now you can recall what I am talking about when I am saying about soil profile. Okay, so there are some soil which do not have distinct these profiles. Okay, so how this profile is noticed by the scientists? What they do, they dig a deep hole of about 6 feet, which is 2 meters. Okay, a deep hole is digged in the deep in the soil, and then they analyze the horizons, the layers, the stratas. O horizons means the organic matter or the upper horizon, and then A horizon, then E. Some soils have E horizon, some do not have E horizon. Then we have B horizon, then C, then R. Okay, so now coming back to the types of soil taxonomy. Okay, and then before like after this what we have studied in 1883, the Dokuchaev's classification, there was another kind of classification that emerged, that is pre-USDA system, that is 1938 classification we call it. Okay, developed in the United States by Curtis F. Marbert. Who developed this? Curtis F. Marbert. While a step forward, it was flawed because it relied too heavily on the assumptions of soil genesis. Okay, and how scientists thought the soil formed rather than observable facts. Okay, so how the classification is dependent on which fact? That how the scientist thought the soil is formed, not on the observable facts. Okay, so that's why there was another need for a scientific and a objective, okay, not subjective, objective and quantitative, okay, quantitative measures to find out the types of soil. Okay, now going to the topic about the paradigm shift and the USDA soil taxonomy. To solve the subjectivity problem, the United States Department of Agriculture commissioned a completely new system. Okay, a complete new system of soil taxonomy is developed. It is not merely a classification, it is a taxonomy. So it has a hierarchical system of classifying the soils, like we have in biology, the kingdom, the animal kingdom, there is a hierarchy from species to to genetics to everything is there. Like here we have the same system while defining the soil types. Okay, the lead architect is Dr. Guy D. Smith. You have to remember him. His name is Dr. Guy D. Smith. Year of publication, it was published in the year of 1975 under the soil taxonomy, a basic system of soil classification for making and interpreting soil surveys. Okay, okay, now let's go to the core innovation. The USDA system abandoned the assumption genesis and based classification study measurable observation physical, chemical and biological properties, exact depth of clay accumulation, specific base, saturation percentage, soil moisture and temperature regimes. On the basis of these kind of things, then the soil taxonomy, soil classification has been done. Then this quantitative approach made it global standards for geographical information systems and spatial interpolations. Okay, and these quantitative techniques provided a good base and data for the soil interpretation, data analysis and scientific observations and research. Okay, now let us see what is the structural hierarchy. As I have said, in the animal kingdom, what we have? We have a funnel. Okay, so as I have informed that the soil taxonomy is based on the hierarchy, the structural hierarchical system, because it is inspired from the biological classification of that what we have studied, that there is a domain, then there is a kingdom, then under the kingdom we have the phylum, okay, and under phylum we have the classes. So like that, this soil taxonomy is also a hierarchical system. Okay, so under this hierarchical system, what we have is that the first and the broad category is the order, what we are going to study in today's class, the 12 orders. Okay, under this order there is suborder, okay, that is based primarily on the moisture and temperature regimes of the soil. And then we have the great groups, which is based on the presence or arrangement of specific diagnostic horizons. Then we have the subgroups, what is the transitional characteristics of soil. Then we have the family, that the particle size, mineralogy, root zone, temperature. Okay, we then consider the series of soil. From which series does the soil came from? It is highly specific local profiles. Over 20,000 of series exist there. Okay, so our concern in today's class is about the order, the 12 orders of the soil. Okay, 12 types of order are there, which is given by the USDA soil taxonomy. Now, coming to the main topic, the evolution of soil orders. Here also there is a point we have to keep it in our mind, that in the original 1975, when the publication was published, there was only 10 soil orders. Okay, only 10 soil orders were there. So what are the two orders which were included later on? That are the Andisol, and the second one is the Gelisol. Okay, because these two are those two orders which do not fit in the basis of classification what has been done for the rest of the 10 orders. Okay, so classifying soils along a weathering continuum. However, as the global research expanded, the scientists community realized that certain extreme conditions forced soil to behave uniquely, leading to the addition of two new orders. Okay, so what are the 10 orders? Let's see it in a brief way. So first one is Entisol. Entisol means the recent underdeveloped or undeveloped soil, and Inceptisol, the weakly developed soil. Then comes the Mollisol, dark, deep, fertile grassland soils. Then Alfisols, moderately weathered, clay enriched forest soil. Then Spodosols, acidic, coniferous forest soils which least horizons. And Ultisols, highly weathered, acidic forest soils. And then comes the Oxysol, the extremely weathered, iron aluminum rich tropical soils, Oxysols. Okay, and then Aridisols, desert like salt carbonate accumulations. And then Vertisol, shrinks well clay soils. And Histosols, organic and waterlogged soils, peat, made up of peat and muck. Okay, so now we have seen the 10 soils, and we will study in detail about the soil now. And now let's look into the Andisol and the Gelisol. So Andisol, added in 1990, separated from Inceptisols, formed from volcanic ash. Okay, featuring unique amorphous clays and that aggressively lock up phosphorus. Okay, and the 12th and the last one is the Gelisol, which is added in the 1998, separated from various orders, definitely defined by the presence of permafrost within 2 meters of surface, and cryoturbation first, which is called as the first churning. Okay, churning means mixing. Okay, mixing means how we eat foods and that goes into our stomach and it get mixed up like that. The cryoturbation means the mixing of the soil with the permafrost, the all the water particles during the process of freezing and thaw. Okay, so now let's study about the USDA. Okay, let's start from the Inceptisols. Inceptisols are also known as the alluvial soils, the Vangar and Khadar soils. Okay, and it is found around the Indo-Gangetic plains, extremely high usability for agriculture, the backbone of Indian agriculture. Rice and wheat and sugar cane are found in this region. So, hope you will now remember insectisols are the largest amount of soil that is found in India, which is around 32%. If I am not wrong, you can check it also in the Google, that 32% of Indian soil distribution is made up of insectisols, which is alluvial soil. Okay, and these are found, these are good for the rice, wheat, and sugarcane. Then comes the mollisols. Okay, mollisols. Molly is a Greek term which means soft. Okay, and mollisols are normally found in the grasslands. And which kind of grassland? Those grasslands which are semi-arid and semi-humid. Okay, if you have studied the climatology chapter, in the chapter we have studied that the semi-arid regions and semi-humid regions are not too dry to become a desert and not too humid to grow a forest. So what happens? These areas have very fertile soil and they grow grasses like the savanna, the steppes, the veldos. All these are the grasslands. Okay, and this soil, the mollisol, is found in those kind of region. What is its local equivalent? Means in India, what it is locally more or less same as, that is tarai soil. And where these soils are found, these are the Himalayan foothills. In the Himalayan foothills, we found these tarai soils. It has high usability because this is the most fertile soil and very rich in organic matter, and sugarcane and wheat is produced in the soil, and sugarcane and wheat is also a type of grasses. Okay, and then vertisol. Vertisol means, verti means clay. Okay, verti means clay, and vertisol means the soils which are made up of clay. The black cotton soil, the regur soil, it is known as in India. Where it is found? We all know it is found in Deccan Plateau. It has high usability. Okay, and Montemorillonite clays hold vast moisture. Okay, these Montemorillonite clays hold vast moisture, difficult to till. And what are the crops that is grown here vastly? That is cotton and soybean. Okay, and these are called as also cotton soil. Okay, black soil, and this is found in the Deccan Plateau. Then comes the Alfisol. Okay, here comes the Alfisol. So talking about, now we are talking about the Alfisol. Okay, and Alf meaning nothing, but it came from the word pedal for, pedal for. Okay, it came from the word pedal for. Okay, and this is also known as red soil. This is also known as red soil in India. This is found in peninsular India. Moderate to high usability of this soil is there in agriculture, and it is good stability, prone to crusting, and groundnut and pulses are majorly grown in India in this kind of soil. And these soil are moderately weathered. These are the moderately weathered soil. Okay, and these soils are found in the deciduous forest. Okay, let's come to the next slide. Here we have the Entisol. Here we have the Entisol, the recent alluvium. Which are the recent alluvium? We call this as alluvial soil, and these are the recent alluvium. Yet this has to develop a little more to be usable. Okay, or to be called as alluvial soil. These are the recent alluvium soils, and where these are found? In the desert, in the coastal margins, in the dunes. And these have variable usability, lacks deep reserves. Okay, need fertilization for the growth of the crops. And what are the agricultural crops? These are the mustard and millets, which support the which is cultivated in these kind of soils. So entisols are the first order of soil, the lowest order that comes in the USDA soil taxonomy. Okay, and now coming to the ultisol. Ultisol are the ultimate weathered soils. Okay, and this comes second after the oxysol in terms of weathering. So when we will study in the later on in this video about the soil orders, then we will know according to the USDA soil order which soil comes first and which soil comes the last. Okay, I'm now talking about the ultisol. Okay, ulti is a Latin word, and the meaning of ultimus, it comes from the word ultimus, which means last. Okay, which means the last. So now it is known as red or laterite soil in India. It is found in the eastern Ghats and in majorly in parts of Odisha. These are low native fertility. They have low native fertility, low base saturation, and needs organics for the growth of the crops. And what are the fascinating crops we see here are the cashew and the tea, which grow very well in this kind of soil. Okay. And what is the meaning of low base saturation? And what is the meaning of low native fertility? If you don't know what is low base saturation, what is the meaning of low base saturation, then I will upload a video. I will give the link in the description. You can check it from there. Currently, what I am saying, low base saturation in a very brief way, there are some acidic and there are some base nutrients that are available in soil. And the base nutrients are like calcium, magnesium. Okay. These are the base nutrients. And these base nutrients are very much loved by the growth of the plants. But these base nutrients are very much low level, that the below than the saturation level, very much low. That's why this soil is called as the low base saturation soils. Okay, and why this happens? This happens because the soil has been leached by the heavy rainfall. This happens because the soil has been leached by the heavy rainfall and the soil has become acidic with a subsurface clay accumulation. Okay, with a subsurface clay accumulation. So what is the meaning of subsurface? You know, I have talked about the soil horizons. Okay, in there what we find that this is the surface. A and O horizon are the surface, and under this B, C, R, these are the subsurface horizon, and clay accumulate there. Okay, and these are older soil, the Altisol, the Oxysol, these are the older soils, and these soils and these aldizols are older soils. Okay, and these are less fertile than alfisol. Okay, so while studying in this soils in order, starting from lowest order to highest order, I will explain this to you and you will easily remember the facts. Now coming to the aridisols. Okay, when we are talking about aridisols, we all know that arid means dry, and these soils are found in dry climatic conditions. Okay, and these are the desert kind of soils, and this is found in Thar Desert of India. This has low usability. These are calcic and salic horizons restrict the roots and needs drip irrigation. Drought resilient millets can be grown here if we want to do the agriculture. Okay, then comes the oxyzoles. Oxyzoles, as we all know, this is the most highest weathered soil. This simply comes from the word that is oxide. Okay, this simply comes from the word that is known as the oxide. These are highly weathered soil and rich in iron and aluminium. These soils are rich in iron and aluminium, and these are deep laterite soils. We call this as laterite soil. These are mostly found in the western Ghats kind of soil. These are low to very low usability in agriculture. Extreme desilicification leaves only iron and aluminium, hardens, and this also used to make the um, tiles. Okay, mud out of the what we call that roof tiles for the construction of homes. Okay, and rubber and arecanut are some of the crops that is grown here. And what is the meaning of desilicification? What is the meaning of desalification? Histosols. Histos is a Latin word, and it is the histos meaning it means tissue. It is a Greek word, and histos means tissue. Okay. And why it is said as tissue? Because this soil is made up of organic matter. Organic means from the leftover of the plants and the what you say, the plant and microorganisms that live in the soil. And this soil is called as pity soil in India, and marshy soils also comes under this kind of soils. And this is mostly found in Kerala and Sundarbans. This usability, this has a niche usability, and these are waterlogged soils and requires extensive drainage facility for the proper irrigation, for the proper agricultural functionalities. And these develop deep water paddy can be grown here. Okay. So now we have completed the soil orders in context with the Indian relevance. We have completed it now. So what we have studied, I hope you remember this. And now we will talk about the 12 soil orders. Actually, I should have taught first the 12 soil orders, then I should have taught the Indian relevance, but I thought let's first introduce it so that there will be no confusion, a little clarity before knowing about the order of the soil. So before starting the soil order according to USDA soil taxonomy, I have to clarify one thing, that when we are saying about the lowest order soil and then we are saying about the highest order soil, we are not saying here that the lowest order has less usability or the highest order has the high usability in terms of agriculture or in relation to anything other usability. What we are simply meaning here is that the lowest means the newly formed soils or newly developed soil, and the highest means the old. It has been there since millions of years. These kind of soils come in the highest order. But in practicality, what happens, the intermediate soils what comes in the order are very highly fertile, and it has a very high usability for agricultural purposes. And when we talk about the newly developed soil, these are because these do not have had enough time to develop the soil properly. That's why these soils can be used for agriculture after applying the manures, fertilizers, compost, these kind of things. And what is the problem with the highest order soil? As these are very ancient and big, and these are heavily leached out by the heavy rainfall or other climatic phenomena, and the nutrients of these soils are naturally stripped away, which go to the either it is washed away or it leaks to the lower strata of the soil. So that's why in this old soil also we need to have use of fertilizers and other agricultural supportive elements. But what happens in the intermediate soil levels? Here we can see that these soils are very much fertile. They are rich in plant loving nutrients, and here the agriculture can be done very efficiently. Okay. So what we see here, when we go to the lowest order, we see that the time and the weathering has been done efficiently in this highest order soils. And the fertility and availability of nutrition now we discuss. Now let us go to the types of soil. So starting from the lowest order, that is the Entisol and Inceptisol. These soils represent the absolute beginning of weathering timeline. They lack well-defined diagnostic subsurface horizons simply because they have not had enough time to form them. Okay, they do not have enough time to form the diagnostic layers, and found mostly on an active floodplains or steep eroding slopes. Okay, where the soil is active. What does we mean here? Means active means the erosion and weathering process is ongoing and it's very much active in those areas. These lowest order soils are found, which means the entisols and inceptisols. Okay, and here they lack well-defined diagnostic subsurface horizons. So what do you understand by diagnostic subsurface horizons? So I will upload a video where I will clearly define what is the meaning of diagnostic subsurface horizon, but here I want to explain it very briefly. As we have known, there is a soil horizon. When we are talking about soil horizons, there are A, B, C, O, A, E, B, C and R horizons are there. And diagnostic horizons means what? Diagnostic, it means that the scientists could able to diagnose the type of soil from the chemical and physical property of soil. If the soil gives that chemical and physical fulfills that chemical and physical requirement, then only the scientists say that yes, this horizon has diagnostic horizon or diagnostic layer. And if the horizon do not give appropriate or the proper amount of chemical properties or proper amount of physical properties, then it can be said that this horizon is an ordinary horizon. It do not show any signs of a diagnostic horizon. So, coming to the types of order. First comes the Entisol, then comes the Inceptisol. Entisol is the first and youngest dot, zero profile development, constantly turning over. And Inceptisols, the next chronological set, shows the inception of development, features weak cambic horizon, but no majority clay accumulation has occurred yet. There is no majority of clay accumulation has occurred yet. Okay. And what is the meaning of cambic horizon? As I have said about the diagnostic horizon, the cambic horizon falls in the B horizon of soil. And when there is a weak development of this B horizon, that is called as the weak cambic horizon. Okay. After Entisol and Inceptisol, what we have? We have Alfisol, Mollisols, and Spodosols. So after Inceptisols, we have the Mollisols, we have the Alfisols. Okay, then comes the Mollisols. Alfisols, it is found in the temperate deciduous forest, develops a strong argillic means clay subsurface which while retaining high base saturation means it is nutrient rich. As I have told, nutrient rich means it is very good for agriculture. Okay, and then comes the mollisols. Mollisols are semi-arid grassland. It is found in semi-arid and semi-humid grassland. And this builds a deep dark premium organic subsurface layer. What is subsurface layer? When we are talking about this part, the B and then the horizons, this called as the subsurface layers. Then after alfisol, mollisol, what we have? We have the spodosol. Okay, so what is the meaning of spodos? Spodos is a Greek word. Spodos means wood ash. So why it is named after this wood? As we can see in the E horizon, there is a gray kind of soil is found. Okay, gray, which looks as the color of wood ash. That's why the scientists name it as the spodosols. Where it is found? It is found in the cool acidic pine forest. It creates a sharply leached E horizon. Now you can understand why this is a gray in color, because this is very much leached. There is no nutrient left in this horizon. And a dark spodic subsurface horizon, and here we found a dark spodic subsurface horizon. And here is a note that aridisols represent the arid climatic path forming desert soils defined by salt and carbonate accumulation. This is about the aridisol, which is not in this slide. Now we will talk about we have now discussed the intermediate. Now we are talking about the highest order soil. Highest order soil are formed on flat, stable surface in warm, wet climates over millions of years. Extreme time and relentless rain washes away the nutrients, resulting in a very low base saturation. So as I have told you, what is base? Base is the calcium, the magnesium, the nitrogen, the potassium, the phosphorus. These are the base nutrients which are very much helpful for agriculture. And these soils, the Altisol and Oxysol, lack in these nutrients. These are the base nutrients. Okay, and this soil become acidic. So why it is called as acidic? Because acidic soils have highest amount of hydrogen. Okay, in the soil, hydrogen and aluminum, these are the acidic components which are found in the soil. So talking about Altisol, highly weathered acidic forest these are, and characterized by thick clay horizon but heavily leached of primary nutrients. And then talking about the Oxysol, as we have studied, these are the laterite soils, red laterite soils. Okay, and then absolute taxonomic ceiling. Why it is called as ceiling? Because according to the time and weathering phenomena, the oxysols are the most weathered soil, incredibly old and washed out. Almost no original minerals remain, leaving only red, yellow, iron, and aluminum oxides, and very poor native fertility without intense management. So, we are talking here about when we are saying that intense management? Intense management means application of fertilizer, manure, compost, and proper amount of water. And where these soils are found? These are found in heavy rainfall areas like tropical areas. Okay, where the rainfall is very much in higher amount. Now talking about the other four category of soil which do not fall under this time and weather mechanism of classification for the soil taxonomy orders. Okay, not all 12 orders fit neatly onto the weathering timeline. The four specific orders completely bypass the time sequence. The four orders, what are those four orders? We will see it. Okay, one is extreme parent material. I have told you about the Andisol. Okay, Andy means ash, and where this is found? This is found near the volcano. Okay, volcanic landforms. It is added in 1990 and found first in Japan. Okay, in the active volcanic areas. And then the second one is the extreme saturation. So when we are talking about saturation, which soil we are referring here? It is histosol. Okay, we are talking about the histosol. Histo means tissue. So which kind of tissue? The accumulation of cells of the dead plants and animals. Okay, the microorganisms. This soil is formed. Then we are talking about the specific mineralogy. So which kind of soil is this? This is vertisol. Mineralogy means this is vertisol, which is also called as the black cotton soil in India or regur soil in India. These are the vertisol. Okay. And when we are talking about extreme temperature, that is about the gelisol, which is absent in India because India do not have a permafrost kind of soil. So, formation is dominated by one extreme physical condition that overrides the standard rule of time and climate. That's why these four are treated differently. So now let's see the volcanic ash and extreme weather. The Andisol added in 1990, extreme parent material formed directly from volcanic ash featured unique amorphous clays that aggressively lock off phosphorus and dictating very specific agricultural management. And talking about histosol, extreme saturation, organic waterlogged peat and mucks dominated by entirely by wetland and bog conditions where the decomposition is handled by the lack of oxygen. What you are saying? The decomposition is handled by the lack of oxygen means when you see the leaves die, the plants, the grasses, they fall on the soil. What happens? Because of lack of oxygen, they stay as it is and they form into peat and mucks. Okay, and then we will talk about the other two exceptions, that is Vertisol, specific mineralogy dominated by zinc well Montmorillonite clays. These soils deeply crack when dry and swell when wet, essentially churning, inverting themselves over time. These are the regur soil or black cotton soil, and Vati means clay. And talking about Gelisol, added in 1998. Driver extreme temperature mechanism strictly defined by presence of permafrost within 2 meters of the surface, characterized by intense cryoturbation, that is forced churning, and that constantly disrupts horizontal formation. Okay, means there is no soil profile development. So here we have come to the end of the soil taxonomy class. And what we have studied that the evolution of the soil classification and the how the weathering process, tells us about the time and weathering process we use for the classification of the soil, and the condition, what are the other conditions that also add some of the, you know, soils which do not fall under the time and weathering process. Those are Andisol, Gelisol, Histosol, and Vertisols. So thank you. If you have any doubt, you can ask it in the comment section.